Hi, hi. Another
Hello.
week, another alignment session.
I'm muted. Okay, hi everyone. How are you doing? Think this is working. Let me check.
Yep.
It is.
So, Carlos, they should be sharing this in Telegram, in Discord. Okay, we already have almost 80 people. Let's wait one more minute to see if we can get to 100, and then we can start. How are you guys doing?
All
Very
good.
good. We survived the storm. For those
There
who
was
don't
a big
know, in
storm.
the in Argentina this time, or in the south, like you get a big storm that is called Santa Rosa, and
Ah,
it gets very windy and rainy. Uh, so it's probably good that there is no Ethereum event here right now, or at least during the weekend. Um,
can you guys hear me okay? I think the connection I
Yeah,
have is
yeah. Perfect.
yeah,
Yeah.
good.
yeah,
Okay.
everything is okay.
Okay.
So if you want, we can go ahead and start.
Yeah. So thank you everyone for joining. As we do every single Monday, we host this session so we can update everyone on what we're doing, what's the latest on Aligned, explain some stuff that we see in the ecosystem and in the ecosystem for CK and Ethereum in particular, share some of our views on recent events, and in other cases, answer a few questions that we prepared from the community so we can explain or reply to particular stuff that you guys want to know. But in this case, we don't have Boris because I believe in Canada there's a holiday, so we
Yes,
don't have
it's
our main question guy. So today we're going to try to make things a little shorter, so we also don't play with my shitty internet connection. Mauro, do you want to start with engineering updates?
sure. Um, Actually, so we are still working in the three fronts of we have been working all these 3 weeks. We are integrating some new features in the CK Arcade, finishing the Circum integration. It's very close, like it's already generating Circum proofs, so you can play on the browser send it to a line and claim points of nothing because there is nothing running, but like locally, just in case. Um, that there were some changes that were needed with the how the public inputs were handled, but the fix is done. Hopefully, over the next days, like it should be finished. Mm, then, for those who don't know, maybe I'll say you're better for this update, but we things on software are running good. Like uh, have
Yeah,
been we have been working a little bit with the Atrax team. Atrax is also going very good. It's doing a snap seek in 24 hours, which is
yeah,
slow because it should be in like 1 hour, but it's working. And now the team has to improve it, get it better. And as always, that's the tech that we will be using in CK rollup stack. So it's very good that is very close to completion. Um, yes, and on the fast mode, the update is similar, or in the verification layer, the update is similar to what I've said with the CK Arcade. We needed to do some changes on Circum. Circum is only available on testnet. I think after these changes, it should be stable. Then at some point we will put it on mainnet. And that's it. Then some small changes. Like feel free to read the full report like we publish every week, and there you will have all the PRs. There's usually a lot of stuff going on. I try to summarize it. Probably around 20 PRs at least, and they are all open. Everything is open source, so go ahead and check the code.
Yes. Okay, perfect. Thank you, Mauro. No, the only thing I would add is that the in terms of deployments, we did this, of course, this deployment in Sepolia. That is important for testing integrations of Ethrex and Aligned, and in particular for the testnet that is being running for Sobra. We will do that migration at some point. So we test the full end to end, and we have already been speaking with that team. And verification costs are going to be important for mainnet. So we need to this integration will be really important with our aggregation service, and also the cost.
Yes.
For those who don't know, the cost of aggregating these proofs, the verifying these proofs, also determines how often a rollup settles. So the more you can amortize the costs, and the more proof you can put in a batch in a shorter period of time, the faster you will be able to settle, and that means faster withdrawals and most likely uh, more efficient markets. But that's more long term. What matters is first getting the cost down so these things can run without needing millions of dollars for operational purposes.
Yes, that's right. That's
Yes.
something I have been talking also with that team. Like they are very interested in reducing the cost. Um, so yeah. Right.
Yes.
And to the next thing, Ray.
Yes. Next thing, have a question for both of you guys. Do you have anything in particular that you guys believe it was relevant in terms of CK or stuff that the CK team has been working on? Diego, you mentioned a couple of stuff behind the scenes.
Yeah. So first, we released with Lambda class some blog posts regarding multilinear polynomials, um, the subject protocol, and its use as a proof system for air. Um, we discussed a bit Whirlaway, which is one of the alternatives to have snarks for post-quantum signature aggregation. And yeah, it's interesting because you have a discussion about what's going on there, some of the alternatives, and in general how the protocol works. It's an interesting alternative. And then I think that another relevant thing, it happened a few weeks ago, but we didn't mention, is Glock, which is verifier for CK proofs in Bitcoin, which shows that things are getting more and more serious regarding CK. You must remember that verifying CK proofs in Bitcoin is something like that is like super costly, because in Bitcoin you don't have something like Solidity or some high level language. You have Bitcoin script, which is like very limited, and doing, I don't know, a simple GROT16 verification natively in Bitcoin is almost impossible. It's like super expensive, doesn't make any sense. So over the last few years, there were like several proposals to make CK verification practical in Bitcoin. You had the BitVM 1, 2, and 3, using different constructions. Each one got way better. I think that the first ones were like super expensive. You also have Collider VM by Starkware. Um, but I don't know, you had like different techniques. The idea was like, okay, verifying a CK proof in Bitcoin is expensive. So what we can do is instead do like something optimistic where you say, okay, I am going to assume that this proof is valid, and you send it to the rest of the network. They verify it off chain. And if somebody finds that there is a mistake, they can submit a fraud proof essentially. Of course, it's been iterated in BitBM too. You had the idea of naysayer proof, okay, which is something which is easier than CK because that is convincing you that a given proof is false, which you can do like much easily. And BitVM3, the idea was it was like more efficient in terms of cost because like asserting that the transaction is correct or disproving it was way cheaper. Still, it's expensive, but it was getting like way cheaper. But it had a huge off-chain cost because it worked with garbled circuits, and the thing was that this circuit was like huge. Besides, they discovered like some vulnerabilities in the garbled circuit they are using. So of course, they needed a new version, and I think that Glock addresses many of these shortcomings. Uh, it works also on garbled circuits, but it does several improvements. And the idea is that in the garbled circuit, uh, basically, uh, if you are a malicious prover and you give like a false statement, what the garbled circuit is going to output is some secret that you can then use as an evaluator to challenge and in that way claim the funds of the malicious prover and slash him. Okay, so that would be kind of the whole idea. This time we're also using these garbled circuits, but there are like several improvements that make these cheaper and practical. If you want, I can comment on that.
So, but to yes, no, I wanted to first ask you a more basic question so people can understand better. Two things. One, I wanted to explain something and then ask you, Diego, and also Mauro. The reason why we're talking about verifying zero knowledge proofs on Bitcoin is because um, by doing this, you will allow or you will unlock the possibility of having secret rollups on top of Bitcoin. And this is important because you don't have a native way for Bitcoin in order to scale and also unlock programmability natively. When you want to do something with Bitcoin, you either go to a centralized exchange or you use a wrap asset version of Bitcoin in another chain. Like you have wrap Bitcoin on Ethereum, and you can use that asset to interact with DeFi, all of these things. All of these wrap versions have a lot of trade-offs. Uh, there last year, I think, yeah, almost a year ago, there was a lot of drama around wrap Bitcoin because it was bought by a company from Justin Sun, and people did not like that. It made the reputation of the company go a little down, uh, and there's still not like an optimal solution for many of these things. So the actual solution is having Bitcoin verify synergy proofs and allowing or enshrining long-term rollups. So there are many different teams working on different types of solutions to allow this to happen. And what Diego is covering is Glock, that is the latest paper regarding how this could be feasible. Now, Diego, my question is more basic, more than the solution. Why are we like all of these protocols? Uh, not only do they need like these Gabor secrets or like in many or these VMs, but they also need like an extension of the protocol for making them secure, right? Like we're talking about having verifiers that need to stake capital in order to participate. Um, why is it that it's not enough to have just these VMs? And if you know how they are going to address the staking, is it going to be similar to restaking, for example?
I can tell if not, Diego, as you wish.
Go
So
ahead.
here's the thing: we doing CK in Bitcoin is very hard. Like
Yeah.
is so what they are doing is not strictly a CK rollup as we know them in Ethereum, because verifying a proof, leaving aside the technical difficulties, is extremely expensive. It's orders of magnitude. It's like 1,000 times the cost, or 10,000. It's impossible. Uh, so then, because you cannot actually do the verification, is that you start having like this parallel network uh, with some people locking funds, because what they are actually designing, at least most of the designs that I have seen, is more of an optimistic rollup, but in the case of a dispute, it gets solved through CK, right? So CK is to show to resolve a dispute. So in that way, like you are not verifying proofs all the time. The usual flow for Ethereum is okay, like is not very cheap, so that's why we built a line, but you can do it every 24 hours, every hour. In Bitcoin, you get bankrupt if you try to do that. I'm not sure if you ask about other stations, they probably that's why you need the node and this kind of a parallel network. At least,
One question,
I
Mauro. So you
yeah.
are not I thought that what you did is optimistically verify the proof. What you're saying is that's
Uh,
not the case.
uh okay, maybe I missed something. Like Diego, like what do you mean?
Yeah, no. It's like verifying the proof on chain would be super expensive. So what you let is the verifier, like the prover, claim that the proof is valid. Then the rest can verify it like off chain. And if somebody finds uh, that something is wrong, then they can dispute on chain. And the idea is that disputing should be like very cheap. That's why you use that. But the thing is, you get uh, a much longer finality. So the first things were like, the first designs were something like, okay, you know that in order to verify this proof, you would have to create, I don't know, lots of transactions. So the idea was that you somehow committed to several things, and then what you could do is engage in some game where you could send a challenge, get a response, and all that. Of course, doing that on chain is super expensive. Then BitVM2, the idea was that you could like chunk the verification, and then you could just go for one of the chunks. But the thing is, it's still like super expensive because it covers like most of a Bitcoin block just to verify the proof. So with the garbled circuit, it's easier because somehow what the prover would do is something like, okay, send something that he claims is going to be true. And the idea is that then the verifier, what he can do is using the garbled circuit, evaluate the circuit, and if it's a false result, the circuit reveals the secret that you can use then to claim the funds of the prover. But it was like the only way they could find, because imagine that in Bitcoin script you can do like very limited things. You cannot like code easy elliptic curve operations over like some field. Of course, you can do it, but you have to represent them uh, by doing like more expensive things because you have just a few operations. Um, and so what you want is to avoid doing everything on chain. So the idea in Bitcoin, I mean, in Ethereum was like, okay, doing things on chain is super expensive. Try to move things outside the main chain and just use the main chain for like settlement. So the idea behind garbled circuits was this, like you can perform your claim on chain, and with that information, the evaluators, what they can do is check off chain, and then if you are malicious, we can submit the secret and then disprove you and claim your funds. Of course, the first design of the BitBM3 was flawed, and Glock solves many of these um, issues. One thing is, first, you need a snark that is small, okay? Because then, if not, you would have to put all the information about the proof there. So, of course, many went for the idea of GROT 16. Of course, Starkware is going more for Starks because they are like post-quantum secure, and it involves doing a lot of hashing, which is something that in in Bitcoin you have, okay, in Bitcoin script. So it seems like a natural solution. Of course, they say that if we had something like OPCAT, then it would be way easier. But the problem is in Bitcoin, you don't have an agreement to add that opcode. So a little bit more on the technical side. So you have this garbled circuit, um, which you have somebody who's the garbler who has to garble the circuit, and then you have the evaluator who's going to, with the information, evaluate. Uh, and you can see the garbler as the same as the prover, and the evaluator would be the verifier. Okay. So the problem with Grok 16 is you have to do Grok 16. You have to do several pairings, and doing pairings in Bitcoin script is like super expensive, and so the circuit is very big, and then you have to garble it, and so it's even bigger. So you'd like to avoid that altogether. So here there is an interesting change in Glock. So instead of using Grok 16, they use a variant of a smaller snark, which is Pari, which works not over R1CS, but over a variant of R1CS, which is like a square R1CS. Okay, R1CS has three matrices. This one has only two. Okay, um, so in principle, it should be the proof should be shorter, and maybe it's easier to verify. The other thing that you have is you have the pairings, and that is expensive. So they used a technique which is called a designated verifier, and there what you can do is, by having the verifier have like some secrets, you can avoid the pairings altogether and replace them by some elliptic curve operations, additions and multiplications. So it's way cheaper. Of course, that makes the verifier not permissionless, okay, because you have this designated verifier, but it offers a compelling advantage, which is no pairings, okay. Um, Another thing is, okay, you have the garbled circuit, but how do you know that the garbler is actually garbling the circuit you want and not something else? Of course, you could do a snark of that, and show that you had the original circuit, which is big, and then you garbled it, but it's not like super practical. Um, so what they introduce is a cut and choose method, okay, where you can, uh, yeah, check whether like some part is correct by selecting that part and having like the garbler like commit to some things, and then you can choose uh, and see whether it actually corresponds to the circuit. Um, yeah, then of course you have like some issues because of the designated verifier. What it adds is, okay, he has to have these secrets and he has to share them with the prover, but the prover cannot learn these secrets because then he could like forge proofs. So there they introduce an oblivious transfer protocol, okay, so that the prover doesn't get to know which secrets the verifier is actually like sharing. Um, and then, of course, you still have the problem that doing operations in Bitcoin is expensive because you are used to doing things with bitwise operations. You don't have like native fields. And so it makes sense to work with binary fields and then to do operations over binary elliptic curves, because now what you did is, okay, I am like taking the pairings out of the equation, and so I can replace it with elliptic curve operations. And so there you can choose an elliptic curve with nicer arithmetic. So I think that those are like the main points.
Okay, I think this is great, and we're mentioning this all of this because unlocking these features and possibilities to Bitcoin also benefits Ethereum and other chains, and people will demand. The market already decided that they want Bitcoin and Ethereum, so unlocking more features in Bitcoin will also benefit the whole market. With this, you can create an amazing new version of wrapped Bitcoin on Ethereum, for example, because you will be able to directly verify. Assuming all of this works, you will be able to verify in the future when we have lean Ethereum and all of these things, the state of Ethereum, for example, in Bitcoin. Many other
It's
interesting, many other interesting things.
it's still like some very complicated and expensive system though. Like it's getting better, like with Garble circuits and everything that Diego explained, but it's still hard. Uh, I think we really need some more operations in Bitcoin. So hopefully, I don't know, maybe I'm gonna rant a little bit, but some other chain that is very similar to Bitcoin should lead the spearhead and show that you can do it. Like I don't know if Dogecoin, if like Zcash, some Bitcoin fork that is very much like Bitcoin but not
Litecoin,
Bitcoin.
Litecoin that is completely
Litecoin,
old.
yeah, yeah, any of those, like they should rally again around CK. They will probably pump because they will be like the first Bitcoin like coin with CK
Yeah,
and
but
show the way. And then the discussion in Bitcoin is going to be a little bit easier, right? I suppose if you have like
well,
this chain with this value running for a year,
we
yeah,
met Mauro. Do you remember? We met a team that was working on on doing that on Dogecoin. I don't know what happened with them.
I don't know. Yeah, but I remember. I think that's probably the only way. And we will need to mutate Bitcoin at some point. It's like a ticking clock. Like
Yeah.
it cannot stay the same forever. Even though I like it, uh, not moving a lot. Uh, if quantum computers can, we will need a patch. So there needs to be some lubricated process to upgrade Bitcoin.
I agree.
Ethereum has it, like, and it is working. And to be honest, all the chains, leaving aside Bitcoin, gets upgrades once a while.
Yes, I agree, and I think we should cut here. But I want us to talk next week about something that I saw today that now that we're talking about quantum security and this stuff, that El Salvador apparently is doing. They have a strategy around how they are managing the bitcoins in order to try to minimize the risk of what will happen if you have quantum computers. And I haven't dived into it why, if it's actually something that you can do or not. I saw that Vitalik commented something. Apparently, is the strategy that they're doing is smart, but I'm not sure. I haven't read it in detail. Um, and I
Yeah,
think
it's
we should
going.
talk about some
It's
of this stuff next week. But yes, Dio, go ahead.
Yeah, no, I think that the thing is, of course, if you have like everything in a single place, then it's very tempting to use a lot of resources and everything. And once you crack it, you get everything. Uh, b- but
I think that maybe we should leave it as a cliffhanger. Like Diego is
yeah,
being tempted to do the full explanation. Uh,
yeah,
Let's
yeah,
let's
yeah.
study it and let's talk about it next week. I think it will be interesting to
we,
share.
we can talk next week. In that direction, I think that there has been a small talk like of CK in Starks. Uh,
Ah,
and doing it fully zero knowledge. I think that we can also talk about that. Uh, not an. I think I'm definitely not an expert on that. Like it's some heavy probabilistic math that I didn't study, but I have heard like a lot of people talking about that. There are a lot of opinions, and it's probably very something very interesting to see or discuss. Hopefully, all the Shiga brains of CK and Starks get into one room and
and then fix it.
get yeah, yeah, or have like rich consensus in what needs to be done, because I have heard like different opinions. But
Okay.
let's keep it for next week.
All right. Perfect. Thank you, everyone. We'll talk next week.
Thank you. See
Bye
Goodbye.
you.
bye.
Bye bye.